When it comes to graphing these exponential functions, the best way to start is to look at a list of values that make the equation true. And to do that, we're going to make a table. So I'm going to list some x values, and then we'll plug them in and see what y equals. It's a good idea to have negative and positive values that you're plugging in so that you can see what's happening on both sides, the left side and the right side of the y-axis. So let's plug in -2. Plugging in -2 means that we're putting a -2 right in this spot here, the x spot. So we would have, I'll write it off here to this side. We would have, when we plug in -2, we have -3 times 2 to the -2. That's -3 times 2 to the -2 is 1 over 2 to the second. So that gives us -3 times 1/4, which is -3/4. So I'll plug that in here. Okay, now let's plug in -1. -1, when I plug it in, I get -3 times 2 to the -1. Now, just like we saw up here, that 2 to the -2 is equal to 1 over 2 squared. 2 to the -1 is equal to 1 over 2 to the first. So I get -3 times 1/2, which is -3/2. Now plugging a 0 in here is the easiest one to do because anything to the 0 power will give me 1 right here. So -3 times 1 is -3. And now if we plug in a 1, we have 2 to the first power times -3 is -6. And then if we plug in a 2 right here, we would get 4 inside the parentheses times -3 is -12. Okay, so let's graph. My first point, -2, -3/4 would be about here. Then -1, -3/2, which is 1.5, would be here. 0, oh wait, sorry, I'm going up. Let me redo those. I did positive y values instead of negative. Okay, so -2, -3/4 would be here. -1, -1.5 would be here. 0, -3, 1, -6. And the last one, 2, -12 would be off of our graph, but it would be down here somewhere. So if I fill it in, it's going to get very close to the x-axis, and then it's just going to shoot downward. Now, is it ever going to touch this x-axis? Well, remember, as our exponents get more and more negative, for example, 2 to the -3 and 2 to the -4 and 2 to the -5, as we get further and further in this direction, right, here's what we're going to get. 2 to the -3 is 1 over 2 to the third, which is 1/8. 2 to the -4 is 1 over 2 to the fourth, which is 1/16. 2 to the -5 is 1 over 2 to the 5th, which is 1/32. So if you look at these fractions, they're definitely getting smaller, right? By half each time. 1/2 of an 1/8 is a 1/16, 1/2 of a 1/16 is a 32nd. So each time, the next fraction is going to be half of the previous one. But it's never going to be negative. It's just going to get very, very, very small. So this graph is going to get extremely close to the x-axis, but it's never going to cross over to the other side. And by that I mean, sorry, it's never going to become positive. It's never going to come up this way. It's just going to get closer and closer and closer and closer, but still remain on the negative side of, underneath the x-axis. All right, let's look at another graph. For this one, we have the graph of the exponential function, and we're asked to calculate the average rate of change. I want you, every time you see the words average rate of change, please, please change it to slope, because that's what average rate of change means, slope. It asks us to go from x equals -2 to x equals 0. So find those points. Here's my x-axis. Here's where -2 is. So I'm looking at everything from here to, here's where x is 0, everything from here to here. All right, so now find the points on the graph from -2 to 0. Well, here's the point on the graph that's at -2. Here's the point on the graph that's at 0. And we're asked to find the slope. You can do this two ways. You could write points and use the slope formula, or you can just start at the leftmost point and count to get to the right point. So to get from this left point to the right point, I would have to go down, trying to make that thick, down a total of 3, and then to the right, 2. So if I have to go down 3 and then right 2, that gives me a slope of -3 over 2. The other option you have is to write this point. This point would be at -2, what is that? 1, 2, 3, 4. And this point would be at 0, 1. And you can do the slope formula. The slope formula is but you're going to get the same answer whether you just look at the graph or do the slope formula. When looking at the graph, always start with the leftmost point and always go up or down first.